Alright, we're going to be starting in about a minute or two, so just bear with us 1 second or so. Alright, we're going to go ahead and get started. If you have not joined us for today's meet, please make sure that you go to today'smeet.com/PerlaScience, and you'll be able to see the messages that you're posting here. So let me just make a quick adjustment to the screen so that it looks correct. We're going to go ahead and get started. If you have not joined us for today's meet, please make sure that you go to today'smeet.com/PerlaScience, and you'll be able to see the messages that you're posting here. So let me just make a quick adjustment to the screen so that it looks correct. Alright, so once you're on today's meet, go ahead and let us know you're here by typing in Taylor is here or Richards is here. And it might help if you have more than one Chromebook, that way they can float around to different tables. So for now, could I have in my classroom table 4? You guys didn't have one yesterday, so grab one today. And then table, that one there. And then we'll have this one here. So just go ahead and type in we're here. Alright, so once I have everyone on today's meet and I've got a message from everyone, then we'll go ahead and get started. I just want to make sure we're all on the same page. So Perla 3 has responded. I'm waiting for Perla 1 and Perla 2. And then any devices in Miss Richards or Taylor's class. Let me type in the message here. Okay, so I've got someone from our tables here typed in where you should be going. It's today'smeet.com/PerlaScience if you're not there yet. So we've got one person from Miss Taylor's class is with us. Now we're just waiting for Mrs. Richards, and we'll go ahead and get started. Sophia, where are you? Actually, I'm going to have you monitor the stream. So your job would be to have it on and just kind of watching it go around. All right, so we have Miss Taylor on. We're just waiting for Miss Richards, so let me just double check here. Hello, this is Mr. Perla. Hey, I was wondering if you guys were going to join us for science today? Yes, we are ready to go, so we're just waiting for your class to get on. Okay? Okay, thank you. Bye. Alright, so we're waiting for Mrs. Taylor's class, or I'm sorry, Mrs. Richards' class to join us. So what we're going to do in the meantime, okay, I want you to, let's review really quickly what we had in our notebooks. Okay? And let's go back to our notebooks and look at some of the things that we had. So you had a variety of different circuits that you had drawn. So I'm going to go ahead and extend here. I'm going to draw a circuit, and I want you to tell me whether the circuit I drew is parallel or series. Okay, so I've got a cell. Okay, I'm going to add a light bulb to it. Okay, and I'm going to use a symbol here. And then I'm going to add a second bulb. And let's label this. So I want you to kind of take a look at yourself. And I want you to determine whether this is a series circuit or a parallel circuit. Okay, so right now you don't have to add this into your notebooks, but just kind of watch up here, take a look at what we've got, and let's talk about whether this is a series circuit or a parallel circuit. Jackson, what do you think?
This is a series circuit. Since there isn't multiple paths for the electricity to follow, it's basically it only follows one path.
Okay, so the electricity comes out of which side? The right side or the left side of the cell?
Left.
The left side. Electricity is going to come out this way. It's going to flow through this first bulb, through the second bulb, back to the cell. So what I have is one circular path like this. One path equals series. Mr. Perla's room. Todaysmeet.com/Perla Science. Uh-huh. Okay. Yeah, do you have the YouTube thing up and going? Okay. All right, perfect. All right, bye. All right, so one path means that this is a series circuit. Okay? Let's draw a different one. Cell, bulb, second bulb. What kind of circuit is this? Celeste.
It's a parallel.
Why is this a parallel circuit?
Because the electricity has two ways to go.
It has two ways to travel. Now, it comes out on its own here, but once it gets to this point right here, you notice the electricity can go two different ways. It can go up this way, and it can also go which way? And it can go to the right. So here it goes this way and then it goes back. There it turns and comes around. So you have two different paths. Mr. Perla's room? Yes, I do. Okay, perfect. Thank you. Bye. Miss Kaylee, grab Aubrey. She's going to your house after school. Okay, perfect. All right. So here I have two paths. Therefore, two paths means that this is a parallel circuit. All right. Can you see the difference between a series circuit and a parallel circuit?
Yes.
Yes.
Okay. All right. So what we're going to look at today, Ms. Richards' class should be with us, so let me just make sure that she's there. So there she is. She is now with us. So we are ready to go. All right, so what I want to do today is I want to look at a particular problem called solving the string of lights problem. Okay, so what I have that I'm going to show you is as follows. Okay, so in our class, this is review, and I'd like to see how many of you guys can actually go through this again. But what I have here is what you would normally refer to as Christmas lights. Okay, now, one of the problems with these Christmas lights is that they don't necessarily work the way that I would like for them to work. Okay, one of the problems that I have with it is as follows. IT helpers, can I have someone bring me the power strip from way over there? The black one? Hakeem's got it. Sam? So there should be a long black one. Can you unplug it and then extend it? Yeah, so unplug whatever is up there. Alright, and then bring it. No, leave it there. I want the other end. Alright, so untangle it there. Alright, so what I'm going to do is I'm going to plug in these Christmas lights, and you're going to see that they don't quite work. Okay, now I know what is wrong with these lights, because all I have to do is go in there and fix them, but I want you to see part of the problem that I encounter with these particular lights. Okay, so I'm actually in the process of fixing the bulb, so you'll get to see what's going on. But once the bulb is fixed, you're going to see that as soon as I fix one bulb, what happens to the lights?
They all light up.
They all start working. Now notice what happens if this one bulb breaks. What happens to the string of lights?
It turns off.
They all turn off. Okay, now that's a huge problem, because if I have a string of lights that has 100 bulbs in it, what happens if one bulb goes out?
All the other balls.
The rest of the bulbs go out, which means in order for me to fix that string of lights, what do I have to do, Kaylee?
You gotta fix one of the lights.
I have to figure out which bulb is the one that's broken. Now, if there's hundreds and hundreds of bulbs, how long is that going to take?
Forever.
Okay, it's going to take a really, really long time. All right, so there's got to be a better way to do this. Okay, there's got to be a better way to design a set of lights. Okay, so here is what your job is today. Can I have you, Sophia, just bring it down a little bit, turn it down, so that it's loud enough that you can hear it. Okay. But here's the problem. Okay, a company that makes these lights. Now, if you bought these lights and you discovered that when one bulb goes out, the whole string dies, would you buy more of their lights?
No.
Or would you rather buy a company's lights that if one bulb dies, the rest of them stay on?
Yes.
Okay? So, you work for a company, and your company is no longer selling these lights. They don't sell them because people won't buy them. So it is your job to figure out what is going on here. Okay? So as a set of engineers, what you're going to do is you're going to get together and you're going to try to recreate this problem. You're going to try to figure out what's going on here. So what you're going to do is you're going to take the materials you have, which are light bulbs. Okay? You're going to take some switches. You're going to take cell holders, wires. You're going to take circuit strips and light bulbs, which I don't have here in front of me. Okay, but you're going to try to recreate this. Now, you don't have hundreds of bulbs to do this, but you can do it with a few. So you're going to start off with 2 bulbs, and you're going to build a circuit where if one bulb dies, the other ones die as well. And you're going to know by then that's the kind of circuit that this is. Then you're going to try to redesign that circuit so that if one bulb dies, they don't all die. Okay? When you are finished, your task is going to be to write a letter to the board of this company making a recommendation and say, okay, we found the problem. The problem was that we were building lights like this, and you're going to describe what they've been doing, and you're going to say the solution to the problem is to build lights like this now. Okay? Does that make sense?
Yeah.
Do we understand what the goal is? All right. So right now, what you need to do is you're going to have to grab your science materials, and start to build a circuit that has 2 light bulbs where it does exactly what this does, which is if I take one bulb and make it stop working, the rest of the bulbs stop working. If I fix the bulb, the rest of them come back on. Okay? So that's your first task. Your first task is to figure out what kind of circuit these lights are using. Once I know what kind of circuit they're using, then I can move on to the next step. Okay? So for now it is 3:03. Let's go ahead and go till about 3:15, 3:20. See if you can build the kind of circuit that is operating here. Okay, we're going to touch base in a few minutes. So I'll go ahead and mute the microphone for the other classrooms and let you guys start building. Any questions or concerns, make sure you post them on today's meet, and then people in other classes will be able to respond, or if there are no answers, I'll respond to them. Okay? So let's go ahead and grab your science materials, start building circuits that go out when one bulb dies. Right, so that was pretty interesting. Now we're gonna wait a few minutes because Mrs. Richards and Miss Taylor's class are coming back in. So we're just gonna jump right back into where you were, which is continuing to build the circuit. So at this point, we're not gonna be able to get through it all. So the goal right now, Isaiah, Elia, the goal right now is to build a circuit that has two bulbs. When you make one of the bulbs die, the other bulb dies. Okay, if you can build that circuit before the end of the day, you're in good shape. Okay, so continue to work on that instead of, we'll set the deadline till about 3:30. So we'll touch base in about 13 minutes and then see where we are from there.
Okay, so what we do
Alright, so we're getting to the point where in our class we've got a lot of kids that have already figured out what kind of circuit this is. So if you're in Miss Richards or Miss Taylor's class and you have successfully built circuits where if you turn off one bulb, the other one turns off, go ahead and put a message in today's meet to let us know that you've successfully created the circuit. Otherwise, we're going to have a team here in our classroom come on up and create that circuit under the dot cam so that everyone can see what that circuit looks like, and then we'll identify which circuit it is that's being made. Okay? Alright. So let us know if you have built that circuit, or if at least one team in your classroom has successfully built that circuit. Thanks. Alright, so if we take a look at today's meet, we discover that one team in Miss Taylor's class has it working. Another team in Miss Richards' class has a circuit where if they take one out, the other one still works. So what we want to do is actually show what circuit we're talking about and build it. So Aliyah, your team is using double cells. So go ahead and bring your circuit up here and walk us through how your team built it. And show us how if one cell dies, or I'm sorry, if one bulb dies, the whole circuit dies.
One cell.
Alright, Ms. Richards says, never mind. They did it, but it's very dim, which is true. Okay, so our class also had a dim one, so one team decided to hook up the cells in series to make sure that they had bulbs that were bright. So hopefully you can see the entire circuit here. Let me move the camera. Okay, and so Aliyah, can you kind of walk us through how you set it up?
So first, we connected the bulbs with only one cell. So we connected it as a circle. So the switch would connect to a bulb. The bulb would connect to the cell, and the cell would connect with another bulb. But then we saw that the bulbs were too dim, so we wanted to add another cell.
Thomas, can you get the back switch for me? Hit the back switch, and hopefully that'll give us a little bit more darkness here, so we can see what's going on. Okay. Well, not a whole lot. Okay, but here you can see that the bulbs are actually lighting up. Okay, so Aliyah, can you disconnect one of the bulbs or kill one of the bulbs so we can see what happens to the other? Okay, so you can see there that when she took one of the bulbs out, the other bulb died. Okay, so what kind of circuit is this that you built?
It is series.
How do you know it's a series circuit?
Because if one bulb dies, the other one dies. Or
Okay.
The other one's died.
Well, that's not what makes it a series circuit. What makes it a series circuit?
That's one path.
Okay, it's one path. Can you follow the path? Can you trace the path of electricity? Oh, Callie's shaking her head. She says no. What's wrong, Callie?
It's supposed to come out the no.
She's going the wrong way. She's making the electricity come out of the positive side, which is not true. It always has to come out of the negative side. So which is the path? Okay, so it follows this circular path this way. Now, if there's nothing here for the electricity to continue to travel, can the electricity go here?
No.
Can it get to here?
No.
So that's why it doesn't work. If the circuit dies here, everything that's after that is going to die as well, right? Okay, very good. Go ahead and plug it back in. All right, so that's a very important discovery. The discovery is as follows. So go ahead and take this circuit back to your table. Okay, so the discovery that you've made is this, that if I have these lights and they're working, and I take one bulb from this circuit and I disconnect it, they all go out. So you'll see here, if I unplug this bulb, the whole circuit stops working, which tells me that all of these light bulbs are hooked up together the way that team just did theirs, which is all the bulbs are hooked up in series, meaning there's only one path, and once I break the path, there's no other way for the electricity to travel, so the rest of the bulbs die. Okay? So the question that I asked you was, what kind of circuit are they using in these lights? And you've answered that question. What kind of circuit are they using?
Series.
They're using a series circuit, which means that is Christmas lights wired in series the best way to do it?
No.
No. If one bulb dies, the rest will die. Okay? So now the question is there a better way to do this?
Yes.
Okay? So what would be the better way to do this?
Parallel.
Okay, parallel. So now the question comes, can I hook this up so that the light bulbs have multiple paths? The electricity can go to both bulbs at the same time. If the electricity can go to both bulbs at the same time, if one bulb dies, the other one should still stay on. Okay, so it is 3:32. I don't know how much time you're going to need to be able to do this. But my guess is by the time that we actually build this, and then actually test it by having multiple teams come together and then build circuits with 4 bulbs or 6 bulbs or 8 bulbs, that's going to take a little bit longer. So what I would suggest at this point is to just stop. We'll stop here, and we're just going to look very quickly at what the best way to draw these diagrams are. Yesterday I told you that there is something called a schematic diagram, okay, and that's what you use to draw these circuits. So I'm going to show you how you're going to draw a schematic diagram in your notebook here. So I'm going to jump and I'm going to create a section here where we had the string of lights problem. And what I'm going to show you right now is how would you draw these schematic diagrams in your notebook. Okay, so take a look at your notebook. If you have your notebook available, make sure you kind of add these notes to it. So the question is, how do I draw circuits? Okay, and you've already drawn some. You drew some yourself the other day. You drew a cell. You drew a light bulb. You drew wires going to it. And if you had another bulb, you drew it like this, and then you had wires going to that. What's the problem with this picture? Do you see any problems with it?
It doesn't work.
Okay. First of all, not everyone can draw a bulb. Number 2, not everyone does it neatly. Sometimes if I look at some of your pictures, it's kind of hard for me to see what's happening in your pictures because you have lines all over the place. Okay? So the answer to that question is, okay, the key is to use symbols. Okay, and if we use symbols, you're not going to have any problems. Okay, so what are the symbols? Okay? Okay, what are the symbols? I'm going to tell you what they are right now. Okay, the first symbol that you're going to use is for a power source. This is going to represent a cell or any type of power source the electricity is going to come from. Okay, the power source will always look like a long line and a small line next to each other with wires coming out of it. This is going to represent a power source. Whether it's a cell, a wall outlet, any type of power source. Okay, that's your power source. Now, the next symbol you're going to have is for a light bulb. A light bulb is simply going to be a circle with a little cursive E inside of it. Okay, which kind of represents the glass with the little thing inside. What's the little thing inside called?
It's the wire.
Not the wire,
Filament wire.
the filament. Very good. So the little E sort of represents the filament. This would be a bulb. So that's the symbol for a bulb. A motor would be represented with a circle with an M in it. M for
Motor.
motor. Okay? A switch is represented by a wire and another wire that is separated in between and looks like a little door. Now, why would that be a switch? Because it can go up and down to close the circuit, right? So this is what we would call a switch. Anything else that we're missing? Celeste?
Wires.
Wires. What is a wire? Just a straight line would be a wire. Is represented by simply lines. Now, there are some keys to do this. So things to remember. Number one, there are no curves in schematic diagrams. No curves. What does that mean? That means if I'm going to build a circuit that has a bulb and a motor in it, I have to draw my power source like this. I can't curve it, which means I have to put straight lines. I have to have corners right here. They have to be corners. Now, I could put my bulb right here with a little E in it, and then the wires can't curve. It has to go straight up. I could put my motor here, but the wires have to go straight across and then connect with corners. Okay, that there's not very good, but that's what it would look like. Okay, so here I have my power, bulb, and motor. Every schematic diagram that you draw from here on out has to follow those rules. You're going to use symbols, and you have to make sure that your lines are straight. Okay, which means you got a notebook that has lines on it. Use the lines on your paper. Okay, and make sure they're straight and with no corners. With no curves. Okay, that's the key for a schematic diagram. Now, you can add a lot more symbols to it later, but basically this is the basic fundamentals of what a schematic diagram looks like. As you learn more and more electronic components, you'll just learn different symbols that you can use, and you just add more symbols to it. But this is what it looks like. Maybe tomorrow I'll show you guys some real schematic diagrams so you can actually see. Most electronic devices, when you buy them, inside, if you were to open them up, don't ever open up an electronic device. Most appliances, if you open them up, inside where all the machinery is, will be schematic diagrams. Why? Because if a repairman ever comes, he needs to know what's hooked up to what for safety reasons, right? He can pull out the schematic diagrams, look at it, and see how everything's hooked up, and then he can know how to tinker with it and where to touch things and where to do things. Okay, so it's very important that those diagrams stay in there. But I have a few that I'll share with you guys tomorrow, so you'll actually be able to look at them. Obviously, they're a lot more complicated than this, but this is your very basic schematic diagram. Okay, so we'll leave this at this for today. Tomorrow, I'll give you guys an opportunity to start building that next circuit that shows all the bulbs put together in parallel, so that if one bulb dies, the rest of them stay together. And then we're going to finish up writing letters to the board, convincing them that they need to change their design based on what we are going to give them. Okay. So for now, we're going to go ahead and leave it at this. We're going to wave goodbye to you guys from our classroom.
Bye.
Thanks for joining us, and we'll see you tomorrow.